A hot start scenario for Pluto posited, some big black hole news, and studying AU microscope A pays off. The baby star has a planet. It's Saturday, July 4, 2020. It's Aussie Space Month here on Trekzone. It all kicks off on Monday. This is Talkin Science Uncut, produced live. I'm Matt Miller. Let's get into it.
With the latest science and space news 5 days a week across Apple Podcasts, Spotify, Google Podcasts and YouTube. This is Talkin Science with Dr. Brad Tucker and Matt Miller.
Yes, indeed, Brad is back with me. It is Talkin Science Uncut, produced live here on Saturday. Brad, normally I say Happy Tuesday, but now I have to say Happy Saturday.
And Happy Independence Day to our friends in the U.S. listening today. So you can celebrate instead of with fireworks, some celestial fireworks we'll talk about today.
While you're doing that and celebrating Independence Day, you're wearing a mask, of course.
That's right.
Fantastic, Brad. Hey, we can find you on social media. Dr. Brad Tucker on Facebook, btucker22 on Twitter. Trekzone's all over social media as well. And don't forget we're podcasting as well in your favourite apps. Just search for Trekzone wherever you want to find us. Brad, let us dive into the headlines.
Talking Science Headlines.
And first up, Brad, space smells, apparently.
There is a smell of space, and astronauts have said, something sweet smelling, seared steak, burnt meat. And now they've released a perfume, the Ode to Space, that you can smell like a stinky space station for only $39.95.
Speaking of stinky space smells, NASA's going to pay somebody $50,000 to design a loo for the moon.
50,000 Australian if you want to design a new lunar toilet. You're going to have to go on the moon. And it's actually quite an interesting practical thing because there is toilets in the space station that's designed to act in complete microgravity. The moon does have gravity. It's about a sixth the gravity of Earth. So it has to have a slightly different function and design and mechanism than the one on the International Space Station. So they need a new toilet for when humans are back on the moon in a few years. Obviously, you don't want to be left high and dry with nowhere to go when you're on the go.
I was trying to think of something else catchy to say, but I think you've just summed it up there. Axiom Space, meanwhile, back to the space station. Axiom Space has been given permission, or they have been given permission for a while now, to design their own commercial space station module.
That's right. And, back in 2018, NASA essentially awarded them the go-ahead to do this. And now they've entered into a contract with the company to start building it. And so this is the idea that it would be completely commercial, private space station. So that means you don't have to be a part of NASA or Roscos, or go through their training programs. And Axiom Space has been set up as doing private space interaction. They have an astronaut program they're designing that hopefully will go up on SpaceX later this year. So it's a really big shift in, again, this evolution of space that they hope to be ready by 2024. So again, in only a few years' time.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Just search for Trekzone.
Well, I'm not quite sure whether I'm going to buy the fragrance of space. Might be interesting for the collection, for those and for those collectors out there. Who knows? The Lunar Loo, that sounds interesting. If you can come up with an idea for microgravity, you can net yourself 50K. That'd be pretty handy. Welcome back to Talkin Science. Welcome back to the live components of Talkin Science Uncut. Matt Miller with you in Trekzone HQ. It's Saturday morning, and we're once again diving into the uncut edition of Talkin Science. Let's keep it going. Dr. Brad Tucker and I are going to be talking about one of the planets here in the solar system that has an existential crisis. At least that's what I'm calling it. I guess it's what happens when you're the most recently discovered and the least understood, the furthest away, making it the least understood. Of course, I'm talking about Pluto, the poor planet that isn't a planet anymore. But there's been an interesting discovery Dr. Brad Tucker and I discuss in this Talkin Science Story of the Week.
Talking Science Stories of the Week.
Our first story this week is all about Pluto, that dwarf planet that has been shoved around a bit over the last few decades from when I was at school. Now it seems that it might be more like a inner rocky planet than anyone thought.
I wouldn't say, shoved around. That makes it look like we're just picking on poor Pluto. But you're right. Pluto's always been quite interesting. It's been a place where we've wanted to observe. And when New Horizons went by it in 2015, it was really interested in what the geology, what the topology was like. And it may be that there was or still is a subterranean ocean on Pluto, i.e. liquid something underneath the ground of Pluto.
And this is very fascinating because this is what astronomers and researchers term as a hot start. Basically, it means that just like Earth and the rocky planets, and that's what I mean by that, is that it's bombarded by all these collisions. The surface isn't given time to cool and solidify, basically. It keeps being a liquid, an ocean, and obviously just with how far out Pluto is, eventually it was going to cool and freeze over. But there could be something deep underneath in there.
That's right. The inner planets, as you said, were formed quite quickly, bombarded a lot, so it kept them warm, and it kept them slightly molten. That meant liquid. The gas giants we know formed slow, and therefore they were past what's called the frost line. So therefore they kind of cooled down relatively quickly, formed that gassy state, that atmosphere. Pluto, the question is it more, as you said, towards the rocky planets or the big gas giants? And it appears that maybe it is closer to the inner rocky planets, partially because the Kuiper belt where Pluto is, there's lots of stuff out there, lots of stuff happening. And if there's a whole bunch of collisions happening, well, then maybe this led to the idea that there could be, like the rocky planets, liquid on the surface or under the surface.
What's the chance of it actually being, say, H2O, liquid water?
Again, it's unlikely. We do know there is water on Pluto, or at least something. Most of it is methane. There's lots of other things. And what we're finding is that there's lots of places in the solar system that have liquid stuff, and we think to some degree water, but mixed with other things. And this always makes it, I guess, interesting in what the possibilities are. And even if we sidestep the water question, the fact that there's liquid means that underneath, or if there is liquid underneath the surface, that means it's warmer. No matter what the element or chemical or thing is, by being in a liquid state, it's going to be warmer than it being in a solid state. And that means that then the environment is more palatable, better for supporting life than non-liquid states, and therefore makes it quite an interesting thing. And, it just goes to show how this view of Pluto is dramatically changing, even still today.
And having said warmer, we're not talking tropical holiday here. The surface temperature is about minus 230 degrees Celsius.
Yeah, we're talking like maybe minus 80 degrees Celsius, As I said, it's like Queensland winter versus Canberra winter.
And you do say, Pluto was the last planet to be discovered. It's the furthest out in the solar system, and our understanding of it keeps changing as we keep observing it, keep sending probes out there. Obviously, New Horizons was out there having a look at it, and this is really, I guess, where all this information's coming from. We're analyzing the data of New Horizons.
Yeah, it's still looking at New Horizons data, and as you said, it just shows how much data they collected and how big and powerful it was. Before New Horizons, Pluto was just really this pixelated smudge. But now there's a lot of information, and they're still pouring over data, and it will still continue.
Good on Pluto for being fascinating, continuing to be fascinating. Who knows what is going on out there in the Kuiper belt? Scientists will know when we get out there in our own spacecraft, and we can actually have a look for ourselves. Which would be really, really exciting. Hopefully that's going to happen in the next 100 years or so. Well, welcome back to Talkin Science Uncut, produced live. Matt Miller with you at Trekzone HQ. Reminding you to find Trekzone all over social media. Just search for Trekzone. Facebook, Twitter, Tumblr, YouTube. We're there. We're posting. And Instagram as well. Don't forget that. We're reliving Trek episodes on Instagram. Babylon 5 is coming. I've been teasing it for quite a few weeks. I'm working on it in the background. It is to come, so look out for that one. And of course, Trekzone on podcasts as well. In your favorite app, just search for Trekzone, subscribe, and get our latest episodes direct to your device. Alrighty, let's keep the stories of the week going. It's all about black holes now. While one has swallowed something else, a new quasar has been discovered. This is pretty cool. Dr. Brad Tucker and I are discussing in this Talkin Science Story of the Week.
Talking Science Stories of the Week.
Brad, next up on our Story of the Week agenda, black holes, and a couple of stories in this one this week. First up, it's a black hole around 23 times the size of the sun has swallowed something much smaller.
Something is the key word here. We know we've been detecting lots of gravitational waves. So these are collisions between two black holes. We've also collected two neutron stars collide. We've also detected a black hole and a neutron star colliding. Now, the question is, in this case, we know there is another thing, but we can't tell based on the size whether it was a very small black hole or a very big neutron star. So in short, when a big star collapses and the inside squeezes down to compress the inside of the star, it either forms a neutron star, or if it's big enough, it forms a black hole. And we don't know in this case which one it is. We know that there is a boundary, that there is a limit, and that limit is around, it's about 2.5 for a neutron star. And then you're getting up to about 4 for a black hole. So this is times the mass of our sun. So 2.5 versus 4. This one appears to be at 2.617 times the mass of our sun. So right in that boundary where either doesn't exist or we just don't know which one it forms. So it's quite a very interesting discovery.
And the discovery was made by the LIGO and Virgo detectors in August last year with research from scientists at at your university, the National University down there in Canberra.
That's right. And Australia has a big part in the LIGO gravitational wave search. And this is one of the big goals of it, is understanding the mass and ranges of these very compact, massive objects. We just have never really been able to observationally or experimentally detect before. And, this kind of goes back to a very big part of theory about how stars live and die, which is what exactly I work on. And that is where, when do you form what? And by finding this, what we call this mass gap object, the one in the gaps between the two limits, it's really going to start putting a picture on exactly, the exact physical limitations of what happens to stars. Just as we know that, some stars can explode if they get exactly 1.38 times the mass of our sun. These things are things that we can physically calculate and then go and detect. And this is what it's going to tell us about neutron stars and black holes.
Well, the ANU Sky Mapper telescope scanned the area of space where the waves were detected from. Couldn't find any visual clues, though.
No, that's right. And again, that kind of gives us maybe a hint. We do know that if a black hole collides with a neutron star, it's likely to give some burst of light. We know when two neutron stars explode, they explode and we can see it. But it is a very big blind search where you're looking at lots and lots of area and you may never see it. So even though we didn't see it, it doesn't mean we would have seen it.
Well, our other story here in this overall story of black hole discoveries, a massive quasar has been discovered in the early universe. What exactly is a quasar, Brad?
Quasars are essentially what we call quasi-stellar objects, which is a fancy way of saying gigantic black hole in small galaxy. We can't really say GBHS. But
there's those acronyms again.
Exactly. Essentially, these are galaxies, some of the earliest galaxies. So they're younger galaxies. So the galaxy overall is small, but they're dominated by a very supermassive black hole. So the black holes are usually relatively very big compared to the size of the galaxy. They're very active. So they're swallowing lots of things, doing lots of things, spitting out lots of things. And because of that they're so early in the universe and they're so big, it tells us a lot about how quickly black holes can grow, because those small ones, as we just talked about, will eventually keep colliding to form the big ones. And so by seeing how early you can get, kind of puts an understanding of what's happening in the beginnings of the universe.
And as you say, they're quite active. In fact, they're the most energetic objects in the universe. But we're still not quite sure where they first appeared in the cosmic history.
That's right. You know, we know it took time to form things. After the Big Bang, we had elements floating around and atoms, and that eventually took time to form stars. There's a gap where we call it the Dark Ages, where there's a period for a couple hundred million years before the first stars actually form. And then it takes time for those stars to explode and start turning into galaxies and things like that. So there's just kind of a time limit where you just need time to form things. And this is one of the big questions. When do these things arise, and how quickly and how long? And also then, how big can you get, how early? And by finding another really, really big black hole really, really early helps put another piece in limitation of how fast these black holes can grow.
And I'm not even going to attempt to pronounce the Hawaiian name that has been given to this supermassive black hole that's been discovered. Can you help me out here, Brad?
No, I have not been able to hear a good pronunciation of it, but it is in trying to keep with some of the spirits that we're trying to do, and that is pay homage and respect to the traditional owners of the land where we use our telescopes, whether that be in Australia or Hawaii. So I thought it was an appropriate choice.
Absolutely, and I don't want to be culturally insensitive to even attempt the pronunciation, but it does mean in English, and the unseen spinning source of creation surrounded with brilliance. I think that is absolutely perfect, and I love the fact that the Hawaiian culture has a name for these sort of things.
It is. As I said, you're right. It's a beautiful choice, and you're right. I don't want to horrifically butcher the name because I haven't heard anyone say it, so I haven't tried to repronounce it yet, unfortunately.
Alrighty, Brad. Well, that is and of course, if anyone from Hawaii or knows how to pronounce this is watching or listening to us, we'll leave a comment and then we can learn, which is what we're here for. To think something that massive formed that early in the universe, it just puts everything into scale, and even astronomers are baffled at how these things work. Who knows exactly what the inner machinations of the universe unfold, and who knows whether we're ever going to find out everything there is to know. I really hope that we don't. I hope there's always a mystery out there. And speaking of mysteries, how an exoplanet is orbiting a baby star is a mystery. And it's one astronomers are trying to solve, because Tess has uncovered exactly this type of planetary system. Dr. Brad Tucker and I are discussing in this Talkin Science Story of the Week.
Talking Science Stories of the Week.
Alrighty, Brad, our last story of the week, and we're coming back to Tess. It's your project, but well, not just your project, but a project that you're working on as well. It's discovered an exoplanet. In of itself, not that exciting, but the fact that it's around a baby star, now that's a little bit impressive.
It's a very baby star. When we say baby, we're talking about the star is 20 to 30 million years old. Now that is a very, very young star. To put it into scale, our sun is 4.606 billion years old. So this is, 150 to 230 times younger than our own sun.
Appropriately enough, it's been named AU Microscopae.
That's right. So it's found in the constellation Microscopium. AU is just the catalog in terms of its order. And so we know it's a very young red dwarf star. That's what one of the goals Tess is looking at, is lots of these red dwarfs. They make up most of the stars in the galaxy, lots of the nearby ones. And so it's a great spot to look for these planets. And the star is relatively close. So it's a relatively close, very young star. And both of those mean that it kind of gives us a way of looking at how quickly or how young planets can form around young stars. When do planets emerge after the star is formed? How quickly can that happen? We know the Earth is about 4.5 billion years old, so we formed from the same stuff the sun is, but it did take some time for the Earth to be collected and formed after the sun did. So what is that limit? What is that boundary? And just how young can a star start hosting planets.
And interestingly, with this one, it's about the same size as Neptune.
That's right. So this is a fairly big planet, what we call an ice giant, as you say here in our solar system. So it's not like a Mercury-sized planet, but it's also not like the common big Jupiter ones. It's one of these more, I guess, medium-sized planets. Neptune's are common in other solar systems. So the fact that this one is a young star with a big Neptune is a very interesting find for what exists out there, and allows us then to start looking at planet formation, star formation as a whole, and what that means for our own solar system.
Well, it's interesting too because AU Microscope A is part of a nearby collection of stars called the Beta Pictoris Moving Group, which takes its name from a bigger, hotter A-type star, and that one harbours 2 planets. Interesting that this area is finding these planets, but these 2 systems are very different.
Yeah, I mean, they're completely different. And this is exactly what the whole project of TESS is about, is kind of doing a local census of what's in our nearby neighborhood, and the range of stars that are hosting planets, how many, sizes, ages, distances, putting the whole picture of the family together. So just as we want to know the older ones and the bigger ones, we want to know the smaller and younger ones too.
And interestingly, with AU MIC-B, as it's affectionately nicknamed, it's orbiting every 8.5 days. It's a little bit close.
It is. And that's partially the fact that because this is a red dwarf star, it is much, 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 much smaller and much cooler than our own sun. So you can orbit at a much closer distance and still be not too cooking. But it is, as you said, it's pretty close. So you have a very close inside Neptune of a very young star.
And is there a possibility of more planets, or do we think that that this sort of star probably couldn't sustain too much else?
Potentially. I think there's always a possibility of more planets. Why not? Planets for everyone.
Fantastic, Brad. Well, that is our story of the week, all about AU Microscope A. That's probably not how you say it, but that's how I'm saying it because it sounds good. It's got a double I in it.
Well, that's how I would say it. I mean, the constellation's microscopium. So that's how I would say it.
It's the size of Neptune, and it's even closer than Mercury. I can't even fathom that. It is mind-boggling to think exactly what that entails in a planetary system. Well, welcome back to Trekzone HQ Live. Matt Miller with you as we're doing Talkin Science Uncut. Well, we've come to the end of another live stream and of another week of Talkin Science, Australia's leading science and space news podcast. In fact, I'm pretty sure we're the only one out there going live or producing 5 days a week. It's a monster effort, and I'm so appreciative to Dr. Brad Tucker for helping me out and co-producing this podcast series. And of course, to you as well for listening and watching to the show. You're the reason that we keep coming back each and every week. Alrighty, well, we have ticked over into July 2020. God knows what it's going to entail for us. But what I can tell you, what I can promise you, is that it's Aussie Space Month here on Trekzone. For the next 4 Mondays, I'm going to be diving into the Aussie space industry, not the scientific research that we feature here on Talkin Science, but the actual industry, the actual hardware of satellites and hopefully humans into orbit from Australian launch sites on Australian vehicles, which I think would be absolutely cool, and especially since Stargate Atlantis suggested that it would happen with all those Aussie mission patches that you see dotted around the place. So that kicks off on Monday with Dr. Jason Held from Sabre Astronautics. They've been given the contract by the federal government to build our Mission Control Centre, and they've got a couple of projects on the go at the moment, which is really fascinating. Dr. Jason was absolutely fantastic to meet him and chat with him for 15 minutes. And we're going to be doing that each and every Monday for the month of July 2020. So be on the lookout for those episodes posting on Mondays at around 9 o'clock Australian Eastern Standard Time. Of course, if you don't want to do the time conversion, well, you need to subscribe to Trekzone all over social media, Twitter, Facebook, Instagram, and Tumblr, because you'll know then when the episode is posted, because I'll be posting about it. I'll be talking about it. But it is, like I said, Monday at 9 o'clock Australian Eastern Standard Time, the first episode of Trekzone's Aussie Space Month will premiere. Looking forward to that one. Looking forward to Talkin Science back on Tuesday, and another edition of Talkin Science Uncut produced live next Saturday. I'm Matt Miller. Thanks so much for watching this live stream, either live or on delay. If you're on YouTube, like would be fantastic. The other button works as well, but I don't know why you would use that. And of course, comments. Let's have a chat in the comments about any of the stories we featured today. It'd be really cool to engage with the community, with my viewers, with you, the viewers. That would be absolutely fantastic. So that's comments. I think I've covered everything off. I'm a bad YouTuber because I still have that broadcast mentality, but I'm getting there. And I'm looking forward to premiering my chat with Dr. Jason Held from Sabre Astronautics on Monday, as I said, at 9 a.m. Australian Eastern Standard Time. For now, though, thanks so much for watching this Trekzone live stream. Bye for now.